I think it's time. It's 2 o'clock Vienna time, so we should start now. Hello, everyone. Welcome to this side event called Nuclear Education as a Basis for Long-Lasting Social Impact on People. Um, my name is Pratik Lokhande. I will be moderating this session, this side event. And a little bit a brief introduction about me is I am originally from India, and now currently I'm a PhD researcher in Chalmers University in Sweden, and I serve as a director for technical uh, event, the technical team for Generation Atomic, and I'm part of ROSATOM's Impact Team 2050 as well. So I will give a brief introduction to everyone, and then Ms. Faisova and Mr. Sanswari has a couple of slides to share with us, and then we will start discussion. I think that's how the program will be. So we have with us Mr. David Drury, who is the head of Nuclear Knowledge Management section from IAEA. Hello, sir. He has been in nuclear industry for over 40 years, have devoted his time in different companies for different technologies from Magnox, AGR, PWR, uh, and he used to be chancellor for ADF Energy Campus as well. Uh, very glad that you have joined us. And then we have Ms. Renata Faizova, who is head of ESG education for Rosatom Corporate Academy. She is responsible for sustainability and ESG training for Rosatom employees and students, and leads program on carbon management, net zero business strategy, and she leads postgraduate and MBA programs in energy transition. Good to have you here, Ms. Faisal. And then we have our um, other panelist, who is Mr. Sanswari, who is former National Executive Chairperson for South African Young Nuclear Professional Society. He's been nuclear physicist for over 15 years with experience in research and development, regulatory framework, and safety analysis, installation, and licensing. Currently, he is working with MEPhI, and he is also currently he's a PhD candidate as well. Good to have you here with us, sir. And then we have Miss Geni Sunario, who is a PhD, holds more than 80 publications to her name, and she is also someone who is um, representative of Indonesia for a technical working group for high temperature gas reactors. Um, good to have uh, good to have you with us. Thank you. You're glad that you joined. And then we have two young representatives, Mr. Soumojit Mukherjee, who is Russian Nuclear Education Ambassador from Moscow Physics Engineering Institute, who is a PhD researcher there, works mainly in field of economics, which is quite good. He is originally from India and been with Rosatom as their ambassador for Russian nuclear education since 2019. He has worked with several students from different countries, and he's still working with his PhD. So glad that you are here. Thank you for joining. And then we have Ms. Kamila Khuzhazhinova, who is Russian Nuclear Education Ambassador and who is currently at IAEA working as an intern. She graduated from Tomsk Polytechnic University, and she is also fellow of Marie Skłodowska-Curie, which is IAEA program. And she has been engaging in scientific work in nuclear knowledge and management, and has been delivered several events and part of several events all around the world. Thank you. Glad that you are with us. So I will share my screen with a presentation from Ms. Renata Faizova from Rosatom, the Corporate Academy, and she will go through slides. Yes.
Okay, thank you so much, Pratik, and thank you to everyone, to all the speakers, dear colleagues, dear participants who just have joined our discussion. Today, I hope that we will have time to discuss opportunities and challenges which we have in educational sphere, in sphere of nuclear education. I would love to tell about how nuclear education at Rosatom Corporation structured and how we constructed their learning ecosystem. Yeah. So just in the next slide, you can see the system, how it was established at Rosatom, because it is not only about universities, it starts with school time, and this is for us is very important, especially nowadays, because we start to pre-create their pre-interest to nuclear education and to nuclear industry itself. So Rosatom has around 246 Rosatom schools. What does it mean? It means that in these schools, they have elective courses where they promote nuclear education, and kids have they have opportunity to choose these elective courses, and to through the special teachers, with the help of the teachers who is specialists in nuclear industry, and people from practice, so they come and they have like structured courses, and that significantly helps us. Especially it's a very good opportunity for us to encourage kids from mono cities where Rosatom and our nuclear power plants have like the key core industry for the city. So it allows children to be interested, integrated, and then come back to work for these nuclear power plants. And that became very powerful tool for us. Moreover, we encourage STEM education with a special focus to have like to integrate girls into these elective courses. Moreover, as another tool in Rosatom Corporate Academy, we have a lot of projects which is focused exactly on the junior projects. Again, we work with those schools. We try to make additional mock courses and additional competitions, opportunities, winter and summer schools, opportunities for children to be integrated. And then finally, we have enough already enrollment students who is ready to go to colleges and to enter universities. As you see, we have in Russia, we have around 18 key core universities with a focus to nuclear industry. And every year, Rosatom employs around 2,000 graduates. But what is very important that nowadays we still have like a strong demand for more than 3,000 graduates. And what is very important that we prepare those still like graduates not only to work in Russia, but before we enter other countries with like our business, we also start first with creation, either it's representative offices of our university, or we enroll students from different countries where Rosatom has nuclear power plants or construction. So we start to take this kind of responsibility because we don't want to have only professional specialists from Russian side, but also to create ecosystems, sustainable ecosystems in different countries where we have our business. Then after universities, we also hold, we give two opportunities for our employees, and this is the key opportunities is for them to encourage their knowledge and tech trainings and reskilling trainings at Rosatom Technical Academy, and also in Rosatom Corporate Academy we we offer more than 400 different programs to train, to improve managerial skills, soft skills, and also nowadays with a great focus on ESG training and sustainability function. So we do understand how their business changes very with a high speed, and that's why we offer different opportunities, and we should, as educators, let's say, in our educational ecosystem, we want all the time to be one step ahead before business needs a certain let's say stuff in industry. But as you all of you understand, that nowadays it's a little bit challenging, and still we have a lot of things to do. So in the next slide, just a few things and in which we try to focus on. So we understand that in terms of digitalization, development of artificial intelligence, and all these new innovations, we first of all, we already have strong demand in more than 5,000 professionals in IT. We like our business, this is our business demand, but also we understand that this should be significantly integrated in our educational ecosystem. Especially we do a lot in all these main pillars, so we integrate digitalization and different tools of VR for our training, for like our core education at universities. But what we expect that definitely it will significantly reshape in future the whole nuclear education, and it's already started to simplify significantly the process of education and the design of our educational programs. Nowadays, as an example, our universities offer more than 50 programs at bachelor level in different fields of which is connected to nuclear, which belong to nuclear education, and all of them significantly changes and focus on this, let's say, reshaping, and is like those programs are significantly agile to new realities. But what we do expect that that will significantly attract students, it will attract people, and like attract, because it, first of all, it will be more interesting, and also it will be significantly entertaining maybe, yeah, and that is how we are planning to solve our let's say promotion of the core education. Moreover, we also are trying to integrate this in our tech trainings, and we understand that with the changes and focus on energy transition and demand from society on like greener decisions and solutions, we understand that focus to nuclear energy itself and other green industries will be significantly increased. And that is why we already started to reshape, and we all the time reshaping our professional development programs for those people who are in our industry, but they need to be they need to gain new skills. And that is why also not only at our country, but also wherever Rosatom is represented and only emerges, we start with like creation this kind of nuclear power plants training centers and integrate this into our ecosystem. And the final, what we plan and already working on to take such kind of responsibility for the society, for those people who will come or probably in future will lose their jobs because of energy transition, maybe we hope like from oil industry, from coal industry, those professionals and employees from this kind of sectors definitely will need to be reskilled and gain this kind of knowledges, which we are ready to train and present them. And that is why this is our final focus on those people who is not nowadays employees or youth, but those who will definitely have new challenges. And we are ready to take this kind of responsibility in future. So here I would like to stop my presentation. Thanks. I just wanted to say a few things on what we are focusing and how our educational nuclear education learning system is shaped. And I hope that during our discussion we will focus more on the challenges and opportunities which we have, all of us, we face nowadays.
Thanks a lot for that presentation. Now we move on to presentation from Mr. Sansbury. I'll just share my screen.
Okay, thank you. Can they put my presentation on there?
Yes, definitely.
Yes, if you can put it just on the presentation. Thank you very much for the opportunity. I promise that I will try to also be as short as possible. But I just want to give a perspective looking at the nuclear education as a basis for long-lasting social impact and the people, as it was proposed for us to be part of the panel. If you move to the next slide. Oh, yes, thank you. So our prime mission as African Young Generation in Nuclear is to address the socio-economic issues that the continent is currently facing, using that through the promotion of peaceful use of nuclear science and technology, because we have seen how nuclear science and technology globally can transform any country if the country pursues it. If you move to the next slide. Oh, yes. Now, we know that the agenda for Africa 2063, the Africa that we want, it has many aspirations, but one of the aspirations is aspiration 1. It says that we want a prosperous Africa based on inclusive growth and sustainable development. We strongly believe that this requires that Africa makes significant investment in education with the aim of developing human and social development skills through education and skills revolution, emphasizing innovation, science, and technology. And this is also attached to the Sustainable Development Goal number 4, which aims to ensure inclusive and equitable education, quality of education, and promote lifelong learning opportunities for all. So as Africa, we already see that we need to have a lot of investment on this in order to ensure that how Africa can have an inclusive growth and also be sustainably developed throughout, to ensure that the 60% of young people that Africa has, they can use them as a weapon of innovation, of development moving forward. And then that is what we want as Africa. In the next slide, please. Now, we know the applications of nuclear. we have seen that Africa, some of the projects there, although most of them are non-power related, we have seen quite a lot of projects around Africa which are focusing on medicine, scientific research, food and agriculture, consumer product, industrial application. So what we need to do is to unpack all these other economic opportunities, your hydrogen production, your outer space, oil refinery. We have oil. We have some of the discoveries of oil around the African continent. That clearly tells us we need to find ways of saying that how do we use nuclear science and technology? How do we educate the African young people to know that this technology can be applied in so many different forms, in discipline, in different industries to ensure that Africa develops. So we need to do that. We know that Africa is 60% of arable land that can be used for agriculture. There's quite a lot of agricultural projects that we need to educate the African child to say that take opportunities within agriculture, take opportunities within the health sector. We have seen throughout this week, one of the scientific forum for the IAEA 65th General Conference was the race of hope. Africa has a lot of people that are suffering from different types of cancer. How do we use nuclear science to empower the African child in order to solve the African problem? If you move to the next slide. So what we're looking at this, we say that the atom, the small component that we see there, it's one of the things that we must use it in order to develop Africa. So we firstly have to demystify the nuclear technology. We need to educate the public about the benefits of using nuclear science and technology. We need to facilitate knowledge transfer, skills development from the current to the leading generation. I mean, we can see strongly so that we need platforms such as this one that we're invited to share, to exchange ideas and get to know what other opportunities are there. I think the first presentation presented a lot of opportunities in terms of what offerings are they having when it comes to studies in terms of degrees and so forth. So as Africa, we need to start to say that if we want to achieve an inclusive growth, how can we do that using nuclear science? If we move to the next slide, please. Now, this is why it's important for us as AYGN to say that how do we can understand generation moving towards small modular reactors. We know that mostly it's been large conventional power plant, but we need to get to the design. We need to see an African child understanding how the nuclear reactor design is, oversee the operation of a nuclear power plant, ensure that they understand a safety criteria of nuclear are met, performing refueling calculations. I mean, those are some of the things that we believe, and strongly so, that when Africa starts to develop, start to embark on nuclear program, these are the areas of education that should be ensuring that the African child understand them. When you move to nuclear medicine, you can see that the work in diagnosing using X-ray, magnetic resonance imaging, and so forth, ultrasound. One of the things that we've seen that there's now what we call lutetium-177 for the treatment of cancer. Therapeutic use of nuclear medicine is going to gain traction. How do we motivate the African child to take studies in those kind of areas in order to ensure that the type of diseases, the type of sufferings that Africa is exposed to can be able to participate from? We can move to the next slide. Now, one of the key elements of Africa is what? Agriculture and food security. We know we've got those issues. We want to have high yield crop, healthier livestock, disease-resistant plants, use radiation to kill dangerous bacteria. We have seen this week that Ebola has now resurfaced again in Uganda. I mean, those are the things that when you do this thing, we say, how do we use nuclear science and technology based on the opportunities that are presented to us to ensure that the young people, they understand, they take those opportunities and they improve the conditions that Africa is currently having. Non-destructive testing of material. Africans want to embark on nuclear program. We need to develop skills in those areas because non-destructive testing, especially using ultrasound and so forth, it is very, very important because for the safety of the nuclear power plant, for the safety of the reactor, to ensure that when the welding is done, there are no cracking that may result in accidents that are necessary. Carbon dating, is very, very important. Forensic analysis. I mean, one of the things that we've seen is that art, how do we also show them that authentication of art can be done using nuclear? So those are the things that we should start to say that when we develop the African child, we need to focus, we must unpack these things so that they understand that nuclear science and technology is beyond power generation. You go to, we have got a whole lot of minerals in the continent. How do we explore that? We need to find ways to say that. How do we explore that without actually harming the environment? I'll take you back. There are some NPOs now that are taking different governments to court when they do explorations within their shores to check for oil, to check for other things. And we need to educate the public that there is safer ways of ensuring that we can explore and find new minerals. You can do mining, you can do all those other things. So this is why it's important for us to say we need to educate the African child that through nuclear, there is an opportunity for us to develop Africa. If you go to the next slide, please. Now, we talk of uranium mining. We've got minerals, we've got uranium within the continent. We need to mine it. How do we do fuel design? How do we do fuel manufacturing? Those are the very important things because we cannot just be sitting and say, okay, we've got a nuclear power plant. Then what? We need to develop African child to know the type of skills. When they do industrialization, we focus on that. Regulatory agencies, they must be well equipped because when you go on a nuclear program, you need to ensure that for safety, there are safety limits that are enforced at operating reactors. The active material are handled how? We know that we've got the waste that we have to also handle. So those are the things that when you develop the African child, we need to start unpacking them that there are opportunities there, and this is how we can develop the African child. And this is a way we can show that, Africa can develop also. Africa can be where 700 million people can now start access to electricity, access to food, access to all these other things that other continents they might be able to have. So lastly, if you move there, is to say that, there are opportunities out there. We need to find the ways of saying, hence we have established African Young Generation in Nuclear to ensure that we can grab all these opportunities are available and then we take them forward. So with those two words, thank you very much, Moderator.
Thank you for a nice presentation. Yeah. So now presentations are over. Now we move on discussion part of this side event. So I have a couple of questions. Starting from now, Ms. Faisova said there are around 5,000 IT personnel are needed. And also when you look at the numbers that came from United Kingdom, who is building nuclear power, according to Nuclear Workforce Assessment in 2019, for only UK, you need around 3,200 to 4,800 employees every year till 2025. So how do we see the role of traditional educational tool and universities to improve these numbers? Because we don't have that many people coming out of universities who have nuclear background or are willing to go to nuclear because of lasting dogma that we have, that other previous generation had given. So what can be done? Does businesses and government have a more active, should they take more active stance, or how can we leverage young people to join nuclear workforce? If anyone would like to start answering.
Hi, Pratik. So this is Dave Drury from the IAEA.
Yeah.
Hello. So firstly, I'd like to thank the organisers for inviting the agency to participate in the discussion, which is a very interesting topic. So just to answer your question more specifically, one of the areas that the agency does a lot of work in is supporting member states with their workforce planning programs. So that is about making sure that there is strategic national arrangements in place to supply educated and trained staff into the nuclear workforce. And it's a really interesting area to talk about, because there's almost three areas of focus that this sits around. One is the nuclear construction industry, so making sure we have enough people qualified to construct the nuclear facilities and the nuclear plants, which has taken a number of years to grow back, mainly due to the reduction in nuclear construction capability in the majority of countries, not all countries, but the majority of countries post Chernobyl, actually. That was a real impact in terms of making sure we had a sustainable nuclear sector, because the world stopped building nuclear power stations after the Chernobyl event. So that's one area where member states have to really prepare to have that large-scale civil construction industry. And it is really dominated by civil and engineering construction capability rather than nuclear capability. That's what we have found. So the second area is in the supply chain support to the nuclear, not just the construction, but also the operational side of the plant. So what we tend to call indirect employees, so in the supply chain, and sometimes induced employees. So that's the kind of workforce that sits outside the supply chain, but nevertheless is connected and supporting the nuclear sector. So we have direct on the plants, indirect, which is the supply chain, and then what we call induced, which may be 15, 30, 50 kilometers away, but part of the supply chain eventually that supports the plant. So it's quite a complex picture in terms of making sure people are educated and trained and indeed qualified to support those three different functions. To answer your question specifically about is there a challenge around nuclear education and a nuclear workforce, what we have found is when we talk to the big nuclear operating organizations, so from all the countries, from Korea, from Europe, from India, from the Russian Federation, from China, Japan, Korea, everybody, we found that in reality, the majority of staff who work on the nuclear facilities certainly are vocational based workers. So typically 60% of workers on the nuclear facilities are vocational qualified staff, not necessarily graduates. And of the 40% of graduates, typically that varies from plant to plant and country to country, but on average about 40% of the graduate population. What we find is the majority of countries have quite a small population of nuclear engineering graduates, typically 5 to 7%. The rest of the engineering population are made up from mechanical engineers, civil engineers, electrical engineers, I&C engineers, so the more conventional industrial type engineers. And what the nuclear sector tends to do is what we call nuclearize those individuals. So we bring in mechanical engineers and we then train them in some of the unique aspects of working in the nuclear sector, not just some of the components and the equipment and the technology side of it, but also, probably more importantly, the cultural and behavioral requirements that are needed to work effectively in the nuclear programs. So the challenge on getting enough nuclear graduates isn't in reality as severe as it appears at first hand. That's not to say we shouldn't have a pipeline of nuclear engineering graduates. And the model that Ms. Feyzova talked about from the Russian Federation is a really good example. The Russian Federation model is an extremely effective, if you like, natural infrastructure that exists where industry is very closely connected to the educational pipelines that feed the workforce. There are other models that we come across around the world. We tend to classify these as almost market force driven educational models, where there's multiple inputs and outputs around STEM industries or STEM based industries. And there's a lot of movement between engineering qualified staff, say between the petrochemical industry or the pharmaceutical industry into the nuclear industry and vice versa. So there's a much more dynamic environment in those circumstances. And our experience here at the agency is it's actually that more dynamic market force driven environment where there are susceptibilities to having the right number of qualified staff in the right place at the right time. So it's quite a complicated landscape when we start talking about that connection between education, the nuclear sector industry and STEM in general. So that's my starter for the discussion.
Yeah, thank you. And how do we see this in developing world where we have whole of African continent who is moving now to accept nuclear, as well as Southeast Asia where nuclear is growing quite a lot. So how does this play a role in like Indonesia, where TerraPower wants to, not TerraPower, sorry, Thorcon wants to build their thorium and sodium fast reactor, and as well as how does this play in South Africa or whole of African continent?
Okay, that's a really good question, actually. And one of the challenges, of course, in the developing countries is the competition for highly qualified engineering graduates, both from other industries within their country. So, as you said, the petrochemical industry or certainly the electronic and IT industries offer very attractive career prospects for young graduates. So one of the challenges is how do we draw those highly qualified and competent graduates and engineers and scientists into the nuclear sector. The second challenge is how do we retain them? Because again, for various reasons, sometimes financial incentives, sometimes more attractive career prospects, it's not always easy to retain those graduates and highly qualified staff in those industries. Then, of course, there's the other competition of that we often see in some of the developing countries. There's often a draw on those qualified individuals into other countries that already have developed nuclear programs ongoing. So it's a very competitive marketplace in terms of getting supplying the right qualified and educated engineers and graduates into the workplace, and then retaining them. So there's been lots of work in different member state organizations in terms of developing career structures, offering that broader scope of development for those graduates, so that they can see ahead of them a much more diverse professional career within a nuclear organization. And that's certainly something the agency recommends to all our countries we work with. When you start to construct your education programs, don't just think in a linear model that these graduates that come along are going to stay in one job, in one organization, in one plant. You need to build an infrastructure that allows the graduates to grow and develop, and indeed exchange potentially between different organizations to maintain that much broader pool of qualified engineers and scientists in that space.
If anyone else would like to add something, like Sunario or Mr. Sansbury.
Yes, thank you very much. I think it's quite correct that there's a competitive market. We have seen in South Africa, we've got a lot of our experts from Quebec nuclear power plant who were, recruited in UAE because the money was good, very good, I can tell you. So you look at that, it's very competitive, and then you see the other industries taking over. So what is important is also that how do we facilitate the issues of ensuring that universities and also TVET colleges and so forth, they can have a sort of a crop of skills that they develop, especially if you want to embark on a nuclear power plant, to ensure that you've got enough pool of young graduates who can be put through the system and then become developed experts or whatever in their area, different discipline, so that they can assist us to have that nice pool of that. So if you look at now the world, because of the energy crisis, there's going to be probably, if most of the country are going to go nuclear, there's going to be high demand of the skills, different skills within the nuclear industry. And if that happens, you will see now it's going to be very, very competitive. Unfortunately, the developing countries might find themselves in a very, very difficult position because the developed countries will offer good incentives, good career prospects, and so forth. So I think it's one thing that we would like to say, government agencies, the industry itself, we need to find a structured way of developing a pipeline of careers, from artisan technicians and so forth, who can fill this gap when we explore different types of nuclear science and technologies in terms of developing the country. I mean, if you look at the Race of Hope, the way it was presented by DG, is going to say that how do we ensure that Africa there's access to radiation, radiotherapy? I mean, there's going to be a demand for medical physicists, for demand for oncologists and so forth. So it's not only the energy sector that is there going to be a high demand, but also other different disciplines. But we need to find ways of saying, how can we get universities and private business and government to ensure that they develop that pipeline? Thank you.
Yes, Ms. Faisal.
Yes, and I would like to add that I think that, coming to your question, Pratik, about how we should encourage youth to be enrolled and to come to study nuclear education, I think that it's very important to explain, and this is our role, to communicate to society, to explain their role in future. I mean that they impact to the society as a nuclear, as a green energy, and the role of nuclear in the energy transition, and this kind of impacts we should explain to the youth and encourage them to make their impact, because I think that nowadays still not in all the societies we have clear understanding of their role, of their possible role in this transition, to a sustainable future. And I think that that youth is our, I think, the not only future but our hope, and that is why we should communicate more and more to them, not only in those countries where nuclear industry is very well developed, but also in those countries which just started to think about this.
Can I be the next one, please?
Yeah, sure.
Good day for everyone. Firstly, I want to say thank you for organizers of such event, because it's a big pleasure for me to be here. Answering for this question, I want to split it for several levels. Firstly, I absolutely agree with Renata that the first thing we should really understand, we should somehow pay special attention for encouraging youngsters to the nuclear, because in the future we will have really big problem in the sustainability in the human resources. And I want to start from several points how we can encourage youngsters to the nuclear. Can I ask, please, to show the presentation which I sent before?
Yes, yes, sir.
And during, okay, very nice.
Yeah.
First of all, we should increase the number of the events which aimed working in the with the younger generation. To be honest with you, I've made the master thesis, and answering for this question was a part of my master thesis. So here is a slide from defense of the master thesis. At this slide, you can see ROSATOM's projects to form public acceptance. During the abundance, it was decided to split these projects to age groups. On the slide, you can see a scheme of the impact of such projects into the influx of young generation and further qualified specialists in the industry. Among the most successful ones are knowledge icebreaker, when children can win a ride on a nuclear icebreaker based on the competition results, ambassadors of Russian nuclear education, and atomic fission. Asterisk belongs for those events which was organized by the International Center of Atomic Energy, which exist with the support of ROSATOM, of course. Can we switch to another slide, please? At this slide, you can see foreign projects for foreign public acceptance is, of course, encouraging youngsters to nuclear. Electricity Defense has several projects which covers all entire age range. Before 16 is Inspire, and after 16 is Young HPC. The American nuclear community pays special attention to encourage youngsters to the same science, and the distinctive experience belongs to China National Nuclear Corporation. It's organization of a summer camp and several anti-poverty projects. So at this level, we have students who want to study nuclear. Further, at the university, as I believe the main challenge will be the modification of all educational process. I want to clarify this and mention some elements which Renata was mentioned before. Firstly is the format of knowledge. We should change wearable one to the virtual. Thank you, pandemic. During these 2 interesting years, we all realized that online education could be as good as and sometimes better than usual face-to-face education. The second one is type of learning. Sit and listen should be try and see. For example, at the General Conference, I had an opportunity to be a visitor at the virtual visit at nuclear power plant, which now is under the construction. And it was really interesting for me just to walk there virtually, of course, and to see parts of the reactor core, buildings on the side. It was amazing. The second one is teacher. Nowadays, teacher is the person who is in charge of all questions, who is always right. But I believe in future, it should be mostly like a mentor one who is facilitates students to study, who doesn't say you must learn it or something like else. Another point is a team-based learning, when teacher gives a project which can be easily done only by teams. Next one is the curriculum. Unfortunately, as in most education organizations now, we have very strict curriculum, which says that at this particular date and time you will have lecture, in this particular time you will have exams. But for future generation, I believe all of us know about the theory of generation. For alphas, we should change it. The curriculum should be like a floating, just to give them an opportunity to choose at what time, at what date they want to have a lecture, in what format, by the way, online or face-to-face. And the last but not least, I believe all of us recognize it, that books and papers should be at the electronic devices. So previously we discussed what we can do at the level of the schools and the level of the university. Next, we go to the real work. Here, personally, nuclear industry should somehow destroy the belief that in the future they can hire one person and to keep him for entire life with the vertical growth in the career. For future generation, it's going to be a strange just begin the job in 1 year and end it at 37, for example. Therefore, nuclear companies should provide the opportunity for horizontal growth career. And secondly, all work processes should be divided to the projects. I believe that in the future, we will hire the person not for the particular position in the organization, but for the particular position in the project. That's all. Thank you.
Thank you for quick slides and a couple of questions there. Yeah. So one of the things that I would like to ask is, of course, because of pandemic, we are using Zoom a lot nowadays, as this meeting is also on Zoom. So how does this new technologies like artificial intelligence or virtual reality that can play a potential role in educating next generation of professionals, and how can we facilitate that to let's say developing and developed countries? So yeah, if anyone would like to start.
Hi, Patrick. We've got some experience of the impact of virtual learning and blended learning here at the IAEA. So during the pandemic, we continued to provide services to member states around some foundational education topics, which were quite challenging at first to put the right kind of programs together. And a couple of things lessons we learned really. One is you can have a very good outreach actually if you have a well-organized series of platforms and blended learning activities. So that was a good lesson. Another lesson we learned was that whilst you can emulate some of the learning experience, there's still some gaps in the overall cognitive experience of the students. So certainly virtual learning activities, blended learning definitely has a place in the future in the nuclear education area, but it has to be very intelligently applied to be really effective. So my other comment would be the use of kind of virtual technologies isn't really new to the nuclear training organization. Most of the big nuclear training organizations around the world run with simulations, full scope simulators. And these are, firstly, very expensive training tools to run and put together. And secondly, they're extremely powerful training tools in terms of exercising the higher cognitive learning abilities and skills of a nuclear workforce. So the kind of virtual digital technology is very, very embedded in certain areas of the nuclear training and education models. I think the move towards a more kind of blended approach has probably opened up those opportunities to a wider audience, as long as they're applied intelligently. So I think it's certainly a future development that will continue. Sometimes it's actually driven by the students. The young graduate population prefer that blended approach. They prefer to be able to do some self-studying as well as team discussions, rather than do what I did and sit in a dusty old lecture theatre with a professor on the chalkboard. So it certainly has a really positive place, I think, in the future education models. But it has to be done intelligently to get the best value. That would be our experience at the IAEA. Thanks.
And anybody would like to add a little bit more to it?
May just have
Sure,
like some
definitely.
notes here. I would like to add that I think that we should divide this. From one hand, it's like, okay, it's coming, everything coming to the online and blended learning, and this is extremely important tool, I think, both in university for university education and for the training of that tech staff, tech trainings, and but I would like to say focus on their digitalization, artificial intelligence, and the new tools which will integrate not only nuclear education but whole, that system of education. And for nuclear education, I think that this is a very important opportunity because it can attract people, because it will be not so difficult. It can be more attractive because it will be not so complicated or comprehensive like we have prejudices nowadays. I think that's why sometimes people do not want to go to nuclear education, because it's challenging, it's difficult to study, and probably digital tools and artificial intelligence will give them opportunity for the students to innovate more, to easier create this kind of innovations. And I hope that it will it should be integrated intelligently, as Mr. David have mentioned. But I think that this is a very important opportunity for nuclear education. So it will somehow naturally increase there and make it more attractive. But nowadays, what is clear that we already have this kind of solution, and we can somehow integrate it for the trainings, and especially for the staff who is working, for example, in our case, in different countries, in different parts of the world, and they need this kind of very fast trainings which they can get online and or through this MOOCs, different which can be easily and very fast be invented or created. Yeah, thanks.
Yeah. Thank you. Moving on. Please, Ms. Sunario.
Can I?
Yes, definitely.
Can I share our experience on how to enhance education on nuclear in Indonesia? As you know that, of course, maybe at first, under the button Indonesia Atomic Energy Nuclear Agency at the time, up to 2 years ago, we still have the Indonesian Nuclear Energy Agency before it merged into a big umbrella. I want to share our experience when we were in Batam. So we did some dissemination, of course, what we achieved at that time on non-energy and then energy to the university and the public community, etc. by dissemination, of course. According to our experience, this is not so effective one because we didn't have much budget to do some intensive dissemination at the time. Of course, so we had we changed, or we had an idea at the time. Since maybe 8 years ago, we started to have some real target. So we want to design our own NPP called RDA, Reactor Daya Experimental in Indonesian, or Experimental Nuclear Power Plant. Only 10 megawatts. Yeah. So we created the idea to have our own design, Indonesian design, small NPP or something like that. So we started doing that project. We included some university around Indonesia, to include to do together to design that such small NPP, RDA. And then we also include some state-owned company also on our design, and also the local manufacturer. Yeah, the local manufacturer that available in Indonesia, such as the local manufacturer that producing turbine, producing pump, etc. to work together. And then finally, in 5 years, we already had the design of our own NPP until detailed design or something like that. So this is the one way, and I think that this is the very effective way to educate the young generation how to understand about the NPP itself by doing some real work. And we got also the product, the detailed design. And we also submitted the design into the IAEA. Then it already included in the ARIS book in IAEA that Indonesia already designed some small NPP or something like that. So all of the team can be proud of their work. So this is the one way that we have done. And besides the design itself, we also enhance the capability of the young generation for producing the simulator. What simulator? The simulator related to our RDE. The simulator that related with our own design NPP. So we already produced that. And then we celebrate, we disseminated. This is our simulator. We enhance the capacity of the simulator on not only for light water RDE, not only for RDE, but also for light water reactor, for our research reactor. So the young generation from the university can come to us to understand well how the NPP works, how safe the NPP, and they can operate by themselves. Yeah, play with the simulator. Oh, if we enhance the power, the temperature will increase like that. And then if we insert the control rod, the power will decrease like this. It's safe anyway, something like that. So this is the experience that we had to educate the young generation. But after the pandemic, and of course at that time also, there were a big change of our organization. So for agency has just been merged together. So we don't have a special for the agency for nuclear from 2 years ago. So what we did, we do the different activity under the Indonesian Nuclear Society. So this is separate with the government. So from, we call it HIMNI, yeah, Indonesian Nuclear Society, HIMNI. We did the webinars every once in a week about what we achieve on nuclear in non-energy and also the energy. So we did the webinar every once a week. And you know, after these 2 years, we already gathered more than 30,000 participants. Of course, they will participate on their interest in agriculture or in health or in NDT or in nuclear power plant or another, not only nuclear power plant, we also delegate the webinars related with the coal power plant, with the oil and gas power plant. And then we also had some webinar about what is the challenging of the electricity company like that. So this is I think the best way also to educate the public, not only young generation, but all the public, whole Indonesia. We have the participant from east to the west of Indonesia. So this is the effective way that we have done, but not under the government agency. We did it under the private, the association, the nuclear Indonesian Nuclear Association. So this is our experience, how to educate public, because we are now after the pandemic, as one of the speaker already mentioned, we could take out the positive effect of the pandemic. So we could disseminate very frequent by using the online one. And then one thing that you already gave us how does the nuclear education for the communities, society, for young generation, and also for women. Yeah, I think that it is important also to disseminate the nuclear in our country to the established professionals. We already produced also some short video. Yeah, some short video. So not only from the webinars. Yeah. So every webinars, we already produce one YouTube. And then we can cut off also into the very short video. Yeah, this is very effective one also, and not expensive. Yeah, and this is the best way, I think, to educate public about the nuclear, because as you know that Indonesia already 50 years fighting for having the NPT, but not yet come. So the one way that we, the target, yeah, the first target that we have to achieve is how to persuade our president. So if our president have a mindset of, okay, let's go nuclear, so we can construct the NPT, of course, in Indonesia. But this is not the easy one. So we have to find out the effective way, how to educate public about the nuclear, so they can agree, so we can enhance the public acceptance, of course. And then what is the IAEA can contribute? I think that we can ask the IAEA also for making education by producing some very interesting short videos related to the benefit of nuclear for both non-energy and energy also, with the language that is very easy to be understood for the public community. So not use the very high level of the scientific way. They will not understand that. If they couldn't understand the language, they don't want to see the video until the end. So this is maybe we can ask the IAEA, maybe the IAEA can produce a very short video with a very easy language that can be understood easily for the common public. I think that's all of I want to share about our experience. Thank you.
Thank you. You touched on a couple of topics like women in nuclear, and then as well as how to grasp people's attention, because our attention span is getting lower and lower and lower. Then that's why we have new tools of social media like Instagram or TikTok, where you post short videos and then you grab attention. So I would like to ask Kamila and Soumojit, who are our young representative, about how do you see this social media playing a role in nuclear education, as well as how this kind of transform your society in general, and what can be done to attract a bit more young persons to nuclear as well?
Thank you, Pratik, for the question. I think I can start. I would say that social media plays a massive role for the youth right now, especially for children who are, for example, finishing school. Yeah, they are in last years of their school and they want to see what options they want to study in university or college. For them, they are using Instagram or TikTok or even YouTube every day. So they have a good source of information where they can get. So we at our project of ROSATOM Nuclear Education Ambassadors did an experiment, which is still ongoing, that we created, all of our ambassadors created our special accounts, which was only related to nuclear physics and nuclear science. So our only objective was to create a social page on Instagram. I, for example, created on Instagram. Kamila created one on TikTok. So the only objective was to ensure that to make post daily or weekly, and our job was to spread the word about nuclear, what nuclear technologies are there, and what are the opportunities to study nuclear in Russia, just general information. And the response that we got from our countries, not just our own countries but all over the world, was massive. For example, I am an Indian, just like Pratik is, but I got responses from people in Bolivia, in Paraguay, in Cuba, who would like to learn about nuclear physics and would just wanted to know how they can start. For most people in the world who are not in the developed countries, for example, people in the African countries or people in the Latin American countries, for them it's a question not just about learning or knowing about nuclear physics, but also where to start, because they don't have the proper resources or the research centers that are probably available in India, USA, or Russia. So like for example, right now I'm in Moscow, so I can go to a new university where I study, and there's a research reactor right inside the university. So if I want to study nuclear, I can start just right there. I can go to a professor and get information about that. But if you are living, for example, somewhere in Chile, your nearest university does not have the capability or the research field or the people who are trained in this field to give you information. Your best place is to go to the internet and to find out where you can go or where you can study. So in that way, the field of social media is absolutely huge. I would also say that I can give you a very interesting example. Since I started my account, and I did not write anything that I work with Rosatom or anything, just a simple account. And we, through my account, another guy from the BRICS Energy Summit called Vadim, he found me. He just found me somewhere. And then we started talking about how energy works in the BRICS region and how we are working to develop nuclear energy in that field. And from that experience, we started doing events for the BRICS countries. And we have now spread over to about 2,000 members. And we have, in the last 2 years, we have done about 250 events just for BRICS countries and how students there can learn nuclear and spread the word about nuclear. So I would believe that in terms of capturing an audience, it's a massive thing that you can do in terms of social media, especially for the people who don't have access. And the people who have access, then obviously you give them opportunity to come and study in different countries. Pratik here, I think, went to UK to study, and Switzerland, to Sweden. I came to Russia. Kamila is from Kazakhstan, who came to Russia. And there are a lot of people from Indonesia who are working with Rosatom and are studying under the Rosatom scholarships in Russia. So that kinds of creates international community. That something is what social media does is it destroys the borders of physical countries. Yeah. So you are suddenly have an international community which does not understand the guidelines of borders of countries. They can just come together, make a group chat, and just discuss the various possibilities or ideas they have. And that, I believe, is just going to grow in the next few years as social media continues to grow. I believe I would not be very surprised if in the next 2-3 years I see a metaverse with a nuclear power plant in there, and you can go and try some things inside that through VR. Thank you.
Soumojit, I absolutely agree with you that we have a really huge impact for a new generation through the social medias. And I want to move back to the difference between the generation, because the phrase like stop sitting at the computer, stop use your phone will sound like stop walking, come home for generation X and Y. And here we can complain as much as we want that social media destroy our generations, that social medias, they can't be smarter using this. But we have a really successful case in Kazakhstan when chemist teacher tries to explain the chemistry through the anime. Is it sounds right? Anime, the same in English? Yeah, through anime. And it was such a huge success that students all around the world want to study chemistry through the anime. It's the first step to encourage youngsters to watch more videos up to 20 minutes, firstly, secondly, up to 40 minutes on this exactly topic. So therefore, I believe we should pay special attention for this and not ignore social media's impact. Thank you.
Thank you for sharing your experiences. And now we are also seeing the shift from like fossil fuel to green technology. Like recently, there is a report that says around 80% of coal power plant sites can host nuclear power plant in United States. I saw Renato mention some about transitioning from fossil fuel to greener technologies. So how is Rosatom, or in general, where Rosatom is doing business internationally, is leveraging that, and how basically how it's helping other countries to transition and also retain some of the workforce that coal power plant or fossil had for nuclear?
May I? Yeah.
Yeah, definitely.
Yeah, so the idea is that, I mean, that first of all, we have strong demand into like specialists in nuclear industry, and there are different options how we can solve this problem. Yeah, like through the mainstream, let's say, educate new generation. But from other hand, we have all the time like our projects all over the world, and that is why we need to let's say to have them now already. And what do we understand that those people who probably in future or maybe nowadays already do not feel their future in other industries, so we can allow them, and we can already offer to them a lot of trainings and this kind, especially trainings and with new like this VR tools to reskill them, and definitely they will not be like immediately specialists in sphere of nuclear industry, but they can already integrate our industry and already be one of the solution, like, so it's, and then we solve both problems. We solve our business issue, and we allow people, let's say, to be employed and to have more opportunities in nuclear industry. And that's how we look into this problem, because it's not only our business demand, but also this is how we understand that we should be responsible and make this kind of efforts to help people to be integrated, especially in countries where this energy transition already has significantly been held, and or in the countries where still only like nuclear industry or other green energy businesses just started to be emerged. Yeah, so that is our key idea, is to focus on reskilling and help those people who like want to be replaced into the new industries. It's not about youth, but it's definitely about those people who is like a very significant part of the societies in different parts of the world.
Thank you.
Can I
Yes,
add a little?
definitely.
Thank you. So I think there is a very interesting problem right now when we are talking about people who are involved in the nuclear sector. And I believe that it should be resolved at the IAEA level. And that is who can work where. In the example I want to say is, for example, I think Mr. David Drury can give his insight here. For example, there are nuclear researchers who have studied here in Russia. Can they go and work in nuclear power stations in UK? Same problem with India. Can somebody who has trained outside India can go and work in the nuclear power stations in India? Can specialists from Turkey go and work at the power stations at Hungary? Actually, they can, because they are both under ROSATOM. But I'm giving you an example that if, for example, ROSATOM is making power plants in Turkey and Hungary, then there is a possibility that somebody from there who has been trained in Turkey can go and work at Hungary, at PAKSH, and they can get good internship, good training and everything. But for example, for countries which do not have common builders, for example, India has a wide variety of builders. We have the CANDU reactors, we have the Russian reactors, we have the French reactors, and specialists from nuclear usually are trained inside India, are only allowed to work in the Indian reactors. That is one thing. So is this problem that people who work in different countries or study in different countries, I can get the best training in Russia, but what is the use of me getting the best training in Russia if I cannot go back to my country and apply that training? So that is something I believe countries should be looking at to solve, because to set general standards, all you need is to set a general rule of standards that the people who are working in this field will be working on these specific standards, on the specific rules, and as long as they fulfill these rules, they can work and get retrained depending on what kind of reactor it is. But other than that, since I believe it is currently a big problem. Another problem that I believe in this field is that we are talking about green technologies, and when we are talking about green technologies and nuclear technologies, we must understand there is a big gap in understanding the time limits. For example, if I want to have a nuclear power plant, if I decide today, for example, I want to build a nuclear power plant, I have to wait at least 10 to 15 years to get it. And by the time I get it, at the same time, a solar power plant station or a wind power plant turbine station can be set up within 1 year and can provide me that entire time the energy a nuclear power plant is going to be built. So that is a massive issue that I believe, again, should be thought about. Because if we can have talk that nuclear is going to save the world because it is the cleanest and the best energy. And even I currently believe that if we wait till 2035, and I believe Pratik is an expert at this, we will be very close to fusion technology as we have ever been before. So 2035, 2040, I would say that it's a good time to think that fusion maybe start being commercialized. But countries, for example, if a country in Africa were to sign a deal on nuclear power plant right now in 2022, by the time it goes through all the bureaucratic process and starts building, it will be at least 2035, 2038. So at that time, you are already too late to save the world, because you could have spent that much money in the green resources, and the people who are trying to save are already not there. So I believe that something that needs to be done in that field, that we need to train people to get to that area as fast as possible. Thank you.
Okay, if I can just add some comments to Mr. Mukherjee's references around transferable skills, which is a really interesting comment, actually, about transferable qualifications and competencies. So our experience is there's actually quite a lot of interchangeable opportunities if people have a nuclear education to certain levels. So certainly we encounter in some of the countries that we've been talking to this week, we've been talking to some of the countries, say Romania, where they have Canadians working in Romania, they have Romanians working in Canada, they have Argentinians working in Romania, they have Romanians working in Argentina because it's a can-do at the Embalse plant. So we find actually that if an individual has the right technical nuclear qualification and indeed experience, then their skills are transferable between different countries. It's just understanding really the connection between more technology-driven connections than nuclear skills connections. My other comment would be, if we look at, say, the United States, you can hold a license on one particular plant, say it's a PWR, but if you want to then move to a BWR, you need to re-qualify through their training programs. That's very similar to a situation you find in the French nuclear industry or in the UK industry, the Korean industry, and indeed the Chinese nuclear industry. So just having the education doesn't necessarily give you the competencies that you need to be employed in that area. There has to be further evolutions of your individual competencies. But nevertheless, my experience is we're kind of all one big nuclear family, really. We're all part of that nuclear professionalism family that we like to talk about here. So those skills, those competencies are transferable. And often you want them to be transferable because you want to share the best culture and best practices around the world for the betterment of the nuclear capability. Regarding the infrastructure issues, which is really interesting, the green technologies, which I'm a big supporter of. But one of the things that we tend to sometimes miss out in that discussion is the massive social and economic benefits that a member state will pick up because of the nuclear infrastructure process they put in place. So we build these plants, and I've just got some figures here, actually. I'll just read them out. These are from France. So France have about just under 60 nuclear reactors. They have 125,000 direct employees on the nuclear facilities. They have 120 or 115,000 indirect employees in their supply chains. And then what we call induced, which is probably more than 100 kilometers away, 171,000 employees. So it's around 4% of the total national employment workforce because of nuclear, which you will not find when you introduce solar programs or even wind programs, because the infrastructure doesn't need to be as complex and as deep. And the other issue is these employment opportunities, they'll run for 60 years, in some cases 80 years. So they're huge economic benefits to some of these countries. So if we say, where's the edge for nuclear over the green technologies, I have to say our experience is it's in that massive social and economic infrastructure that nuclear will bring to that country for the betterment, because that will also bring the expansion of social infrastructures, schools, hospitals, cultural developments. So yes, certainly the nuclear infrastructure in the future will have to compete and work alongside the benefits of other renewable energy sources, other low carbon energy sources, I would tend to say. But each offers its own. So the solar is very quick. We can get that up and running very quickly. It's very much a kind of short to medium term. Nuclear is more medium to long term. So I think the society can benefit from having a balanced view about how it implements some of those activities. Okay, I'll hand back now.
Thank you. Anyone would like to add to that?
All I just want to ask Mr. Drury that when was the last time France built a nuclear power plant?
Okay, so France are building a nuclear power plant at the moment. It's called Hinkley Point C in the United Kingdom. They've just announced that they're going to build Sizewell C in the UK. I think just this week, Okoloto 3, which is a French EPR model, achieved 100% power operation. I think it was literally this week. I only know that because I was with the Finnish delegation here yesterday at the UN. So yeah, so they certainly have been very active in some of the nuclear programs in Europe.
As well as I think Clement will as well, if you add that. That's an example.
Okay, if I may add something there, one of the things again that we need to consider when we introduce technologies is also the cost of the cost of electricity and the quality of electricity that we do. You know, one of the things that we always have problems with when we talk to the Greens is that they think that they can run a grid of 40,000, 60,000 megawatt on solar and wind and backed by either battery or gas. And we've seen that this is impossible. You know, you need to have dispatchable power on your system in order to ensure that the frequency that you are running at, I mean, we know that the system in Asia, you want to balance that between demand and supply. So if you, like for now in South Africa, we've got a very, very massive problem because of our coal fleet are not performing. We've got load shedding. Although we've got renewable sources there, when we need them at peak hours, we get less. And that's what we're showing to the public that, look, we're not saying we're against the green, your solar and wind and so forth, but they don't perform. They perform between what, 30%, 25% of their installed capacities. I mean, we must be scientifically correct and show them the science also, not only the economics, but the science also behind that. To have a stable, reliable, secure electricity, you need to look at the dispatchable power also on your system. So it is important also to look at that. And then that is where now you find issues of saying that we want to do load following. You know, that's why SMRs becomes a smarter choice, because they can do load following. During the day when you have enough solar, you can use them for other things. I mean, you can follow the load much quicker and so forth. So I think those things important, although it takes a bit of time to build it, but it's important and it's needed in order to ensure that the grid is stable. Because now we're transitioning from coal. What is the next? I mean, for South Africa, we don't have big dams like Norway and so forth. So the next best thing out of coal is nuclear. So that is why it's important for us to say, look, we can repurpose those coal power stations using SMRs, and then you also don't take away the economy, like Mr. Drury said, that, you know, the socioeconomic impact of that. So you don't want to take away, because for us, the coal is in the eastern part of South Africa. So if you go away from that, you are taking the economy also. So you need to make sure that you don't have labor migration by making sure that you repurpose them with something that can benefit the community moving forward. Thanks.
Okay, now we have the last 5 minutes, but maybe I would like to have one last question before I conclude this meeting. Wherever you go, obviously, there are different countries, different states have different regulatory aspects. And in some countries, nuclear is or energy sector is state-owned, and in some, nuclear or even just energy sector is privately owned. But who makes the decision at the end is basically your politicians or political elite about if we want to make reactors or not. In that case, what are the steps that IAEA is doing, or what steps other state-owned companies like ROSATOM or maybe research like research communities in Indonesia are doing to educate politicians or political elites about, okay, nuclear is good and we need that, or how can we educate them as well, because generally they have so much things to do that they ignore some problems sometimes, which is not really good. Yeah.
I can share.
Yeah, definitely.
Yeah. This is very, I think this is a very a good one to hold the issue of net zero emission carbon for our fighting on nuclear, to have nuclear. So in what is we are doing now, of course, we always use that statement because our president already commit to make a success on 2060. Indonesia is committed to have a zero emission carbon. So this statement always we use that one to promote nuclear. And also beside that the issue, we always use that the NPP, nuclear power plant also can be used to enhance the quality of coal or something like that. So there is no competition, of course, between the nuclear and the coal power plant. They both can stand side by side, yeah, for sustainable of our electricity supply in Indonesia. So this kind of issue, this kind of statement, we always use that. And one thing that I also can promote to ROSATOM or IAEA, of course, if you want to educate people, please use women first. I'm not a racist, but woman is very important one, I think. Why? Yeah, this is my opinion, because woman is a pillar of the country. Yeah, woman. So to educate woman, no other woman, no woman has wants her child to live in a difficult in the future. So every woman always wants their children to live well, including the clean air for their health, for their long life. Yeah. So please educate women first. So if you want to initiate some training, please, I mean the woman as a priority. And also, I want to propose also, so the important one is please choose also, or please give a chance for the women reporters to have a training on how the nuclear power plant work, etc. Because this is also the female reporters can hold a important role to disseminate about the NPP in the near future. Okay, that's all my idea. Thank you.
Thanks a lot. And I would like just to add that, that's coming to the question of Pratik, that concerning how we can educate or influence decision makers. I think the main decision maker anyway is society, like in the long-term perspective. That's why we should address society, which will significantly press the governments or state regulators to uphold these decisions. And that's why I just want to continue that we should focus on the youth as the most important and most influential tool to achieve not only green future, but also to promote nuclear industry. So we can influence nowadays, but it will be not so successful. We should focus, I think, on their society itself to be the most influential.
Thank you.
Hi, so Patrick, just to follow up on the comments. So one of the agency's role is to inform the world about the benefits of sustainable energy development, part of which is renewables and part of which is nuclear. So we have the agency has a role to play in informing the public and helping the public, but we don't. Part of our mandate doesn't necessarily allow us to go out and openly advocate certain aspects of nuclear technology, which is, it's not a very well-known fact that, but so often people say to us, why don't we become a marketing agent for nuclear technology? And then probably as much as many of us would like to, it's not officially in the agency's mandate. So when member states request help in talking to the public about new technologies, about informing the public about the options around STEM-related technologies and education, we do a lot of work in that space. And that's how the agency approaches it. We believe that the more we educate, certainly the younger generations, and I know there was talk in one of the presentations, I think in Kamila's, about preschool. The more we educate preschool children about the benefits of different science and technology capabilities, the more we excite them with those technologies and those activities that they may form part of their future careers, the better understanding that the future society will have, as Renata said, and then the better informed they will be to make the right choices. So that's the agency's approach to how we would go about that process. Thanks.
Thank you.
If I can quickly get a word in.
Yes. Sure.
Yes, I believe that the current energy crisis in the world should be good enough as a motivator for all the countries that there is a real need to develop nuclear. I believe that in UK, Rolls-Royce has gotten a massive contract for building SMRs just because of this energy crisis. Before that, nuclear energy in UK was going down. India has come up with a massive program of developing nuclear power plants. So I guess there is in Africa too, there are a lot of countries, Rwanda and Zambia and Ghana, they're all coming up with a massive number of nuclear power projects in the near future. So I believe we already have the force is going on. We just need to keep pushing and hope for a better results in the world.
Thank you. Hopefully we will get there as soon as possible. So now we are about time. So thank you everyone for attending and being part of this lively conversation. And I would just like to have some closing remarks about how we can educate and how educate public and general students, and how can it has a social impact. So basically, since pandemic, we are doing a lot of stuff online. Obviously, virtual learning and virtual outreach through different sources like TikTok or YouTube Shorts is quite a good way to keep engaging youngsters and keep up with them about good things about nuclear. And then we also have to look upon the transition from a fossil fuel to green energies using also solar and wind, as well as nuclear, which we have a slogan for net zero use nuclear, as Ms. Sunario said. But also we have to concentrate a bit more effort about how to retain the workforce in nuclear as well, and that workforce in a significant way, because there are other emerging technologies that can leverage to not to be in nuclear but go into those other technologies. So retaining the workforce is quite a big challenge. And lastly is basically, wherever nuclear goes, it brings its socio-economic prosperity to that area, to that society, which is always good. But only a thing that hampers is a bit more decision making and bit more public opinion. So if we manage to get public opinion shift toward the positive things about nuclear, that would be really beneficial. Yeah, and I conclude my remarks this year. And thank you for attending. Now I stop the meeting and have a really nice weekend. Enjoy.
Okay, bye.
Bye-bye.
Thank you.
Thank you so much.